This is the Physics Lab 1 Constant Velocity by Caitlin Schmidt. Introduction. So I analyzed the motion of an object moving with constant velocity, and the object is a dry erase marker. And I use Newton's first law, which is an object will stay at rest or continue moving unless acted upon by a net external force. And I use the position update formula, which is derived from Newton's second law. This confirms that if the net force is 0, the velocity remains unchanged. Tracker was also used to plot the motion of the marker as it moved, and GlowScript was used to create a model predicting the path of the motion. Then I compared both models and analyzed the similarities and the differences. Conducting this experiment to verify Newton's second law and its derived equation, I used the marker and rolled it across a smooth surface to minimize as much friction as possible and reduce as much net force as possible. I observed the motion after the first push, so no net force was observed. And no net force allows for the velocity to theoretically remain constant. So now for the observations, I also included a screenshot of the tracker video, and the marker appeared to have somewhat of a constant velocity, and I set the mass as 0.1 kilograms. The forces acting on the ball in the y direction included gravity pulling downward and an equal and opposite normal force from the table pushing upward. Ideally, there would be no friction, so there should be a net force of 0. Tracker video was trimmed to exclude the initial push, and I analyzed the motion over around 3.9 seconds, and I used the tracker to plot the position of the center of the marker while it moves across. I also set the change of time to about 0.03 seconds, and the positive x direction was set towards the right, and the positive y direction was set upwards, and the magnitude stays the same. For the coding, I encoded a link to my full GlowScript code, and I also encoded a screenshot to show the most important parts of the code. And the model was using a ball, so I assigned the ball's mass as 0.1 kilograms, initialized the ball's position based on where the tracker started, determined the initial velocity using the first two positions, set initial time to 0 seconds, defined change in time as 0.03 seconds, created a while loop to run when t is less than 3.9 seconds, set the net force as 0, and updated both velocity and position equations inside the while loop. The data I recorded from both the computational model and the observed model, and I included a snippet of my data and also the graph of the observed versus predicted position. So now for the analysis. Both the predicted and observed positions were pretty similar, resulting in comparable graphs and average velocities. The computational model maintained constant velocity, but the observed model decreased and finally plateaued. The code assumes there is no friction, but unfortunately it experienced it in the experiment, and friction caused the marker to slow down and not maintain the constant velocity. Conclusion, according to Newton's second law and the predicted model, the marker should have maintained constant velocity if 0 net force was acting. The discrepancy between my experiment and the computational model was due to the friction from the table. To improve this experiment, I would definitely use a surface with less friction in the future.